hello everyone. Maybe quick words about what you're seeing here, because it's an animation that we've built up this weekend, quickly, just to have something special for Grow. And so that starts with when we have been asked by Nico to talk here together. We were thrilled, and we really wanted to build something to present ourselves and to illustrate our differences and also our similarities. And actually, one of our similarities is that we both like this team of wonderful artists. Their name is Harry and Ellie. I'm skipping their last name because they're coming from Netherlands, so I will pronounce that wrong for sure. So it's not a big deal because their project they're working on is really well known. I don't know, maybe a few of us will know it. It's called Exactitude. Who know that project? Oh yeah, cool. Most of the people. So you know what I'm talking about. This work is amazing. It's about casting people in the streets, basically. And they are literally classifying people together just by looking at them, and to group them together and create groups with weird names sometimes. So, for example, here it's girls from the 7th arrondissement, based on the fact that they're wearing jeans and that they are hanging their handbags here. That's quite special in Paris, especially. I don't know where somewhere else. And the other groups is called Cocktails and Dreams. So we can fly somewhere. So it's a really impressive work. It's running since '94, if I'm not wrong, and it's a gorgeous sociological panorama in a way. So I really invite you, for those who don't know that work, actually, just to discover it. It's really gorgeous. So coming back to our prototype here, so we thought that it could be interesting to use some basic machine learning logic to express the same idea than exactitude. So depicting our similarities with Cyril's and differences. Through a collection of people that could be us, but obviously that are not. But that the common point that we're sharing with these people, that we are quite look-alike. And actually, I can say that it's working pretty well. I don't know what you think. And this is just an overview with running faces. It's already intriguing, but when we put all these people all together, and we merge them into some kind of fading, with a fading process. This is quite uncanny, but I have to say that I can really recognize ourselves. So don't get me, that's not a big deal to have that. That's not rocket science. Actually, we use a basic Chrome add-on just to download a bunch of pictures. And then we use a face align algorithm by Leon Eckert. It's available on GitHub, so yeah, that's it. So I don't know. I don't know if it means something just to create such portraits with algorithms, but we can at least share it with you so you get the idea.
Obviously, that's how it's done. To highlight some of the similarities and differences that we share with Gaël, we thought it'd be interesting to very briefly talk a little bit about our individual backgrounds. My name is Cyril Diagne. I'm a French digital interaction artist. I graduated from Les Gobelins here in Paris in 2008. And with a few friends from the class, we formed a collective called Lab 212. This is one of the first installations that we did in 2008 called People on Pop. The idea is very simple. It's an installation that takes pictures of people and then assemble all these pictures to create a collective dance video. A few years later, this is another project called Starfield, and again, very simple principle. It lets you swing through the stars thanks to a video projector and a Kinect. And maybe a bit more recently, I had the chance to lead the Media and Interaction Design Bachelor in ECAL, Switzerland, where both Gaël and I teach. And I highly encourage you to keep an eye on the students from this school because they're incredible, and we can expect incredible things to come out of here in the future.
So my name is Gaël. I'm a Swiss graphic designer. I'm coming from Switzerland, but I'm living here in Paris, where I'm running my own studio called One More Studio, and I'm doing both print and interactive design. So one of my last projects was that was the collaboration with the Boulek brothers, who are two famous French product designers, and it's called Serif TV. And I've been in charge of prototyping and developing a dedicated UI for that TV. We worked with also, that was for Samsung. And also, like another similarity with Cyril is I'm also producing art installation, like this one that have been presented in the context of the Swiss Literature Awards a few years ago. And also, like Cyril mentioned, I'm also teaching since a while, so mainly at ECAL in Switzerland since 12 years now, where we first met with Cyril, but also at Parsons, Paris for a few years now. And that project is a workshop that I gave in another school here called STN. It was about working with long-time exposure, LEDs, and robots, so a lot of stuff. But the reason, actually, we are here today with Cyril is to present the work we are doing for one of our common clients called the Google Cultural Institute Lab.
Yeah, maybe to put just a quick emphasis on the fact that we're not ourselves Googlers. Googlers is not an employee. We're both freelancers.
Yeah. So what's the lab? So the lab is like an hidden place within Google Paris. Generally, nobody knows who's there. Nobody knows what's going on. Sometimes the place is full of people. Sometimes it's totally empty. It's really organic. There is some kind of real workshop mood there when you're there. The idea behind the lab is to be a place of innovation, connecting freelancers like us and artists with Google technologies and engineers. So the lab has been created as an extension of the Cultural Institute. And for those who don't know, the Cultural Institute is a non-profit group at Google that works with museums around the world and various cultural institutions, and they work on their digital contents. So in that context, all freelancers and artists that are coming at the lab have access to that content, and artworks, archives, any content that are handled by cultural institutes. And all that comes from all over the world, and all freelancers and artists are invited to just dig into it and following their personal interest or skills, invited to create something out of it. And so this is why the project we're going to talk about will be mostly about artworks in many various ways. One of the first project that came out and defined the birth of the lab is the Google Cardboard. So everybody knows that, right? It's a virtual VR headset, and it's been created by Damien Henry, who was at that time a freelancer, and he worked with a Google engineer named David Coase, and they built it together. So from there came that idea of bringing creative coders from outside together and start the lab. So beside both of us, there is a team of really talented people that are developing projects for the lab. So I will just present them all. So that's Chris Chogru, Jonathan Tanan, Jonathan Blanchet, Simon Doury, Bastien Girschig, Romain Casier, and the both of us. Yeah, he's here. And sometime, we're lucky enough, the lab also collaborates with much more famous people like these guys right there, Mario Klingman, Kyle McDonald here, really, that can just save your life with a piece of code. Zach Lieberman, Ross Goodwin, S. Devlin, Memo Hatken here, and last but not least, the father of mode. Remember her? It's him. He's here. We work together. So that's the lab, the idea behind the lab. So working in such context at the lab, among all this cultural content, among all these talented people, artists, engineers, and creative coders, that has quite an impact on our way to work, in a sense. First, because when you go there, you can learn so much from everyone else around you. So I don't know how it is for you, but as creative coder, and freelancer, most of the time when people are calling you, they're calling for help. They're calling you if you have problems, if they need an update on their website, or even fixing their email client, or regular stuff, right? But when you go at the lab and you have a problem, so that's cool because you can ask around, and you'll be the guy who will be boring and ask questions to everyone else around. So. It's a really convenient situation because when comes the time to dive into a new field, something that you never experienced before, like in my case, machine learning, so you can find people around you that will just help you to understand quite fast. And actually, believe me, it feels really quite good just to have this feeling of begin again, to learn something. I believe that I was quite good at what I was doing, and then you start from scratch, and you start by, going on Stack Overflow, asking for everything. And at the lab, it goes faster, because you can just ask around. So the second point is, when you work in such a structure, when you come there, that brings a huge network. So actually, it puts your work experience way beyond what you could expect working on your own. For example, in my case, I still can't believe it, but this year I just signed a DNA with Queen Elizabeth in London. So I worked for the Queen, basically. Here, actually, I'm working on a project with the Smithsonian Foundation based in Washington. It's covering a lot of various museums and cultural institutions in the States and in Europe, too. We worked with pictures from NASA. Actually, I also participated in an experiment about archaeological treasure in India. And lately, I was involved in making installations presented in Shanghai last month, actually. And we even had a collaboration with Thomas Pesquet directly from the International Space Station. So that was also interesting with working with culture. It has blurry boundaries. So it can be a lot of things, and you cannot expect what comes next and how you're going to work with that content. So, for example, someday, you come at the lab, and someone is building a playful experience in AR with an augmented piano, like this. Or the next day, you can participate in a photo shoot at the Montmartre Cemetery just to learn photogrammetry. And then when you come back, you have someone just retouching a virtual sailing somewhere, just with the vibe set up. And it's quite really enthusiastic to see, there's a lot of things everywhere, so you really want to do more stuff. But I think that you all agree that, as creative coder, work should always be like that, like a huge game every day. And but don't get me wrong, as you can imagine, so this is also all this moment when you only look at fixing bugs behind the scene, and then praying for everything runs well for the demo that will happen. So speaking about demo, so what kind of project did we do? So I want to separate just the kind of project that we've done lately. The first thing is that we built a few installations. Like here in Shanghai, it was for an AI summit, and we helped to build the system shown here. It's called Draw to Art, and it was about discovering artworks by sketching. And I got a video here that explained the project. So I'm running it.
Well, what if everyone could use a bit of their own creativity to discover great works of art in a whole new way? Introducing Draw to Art, a new experiment that uses machine learning to match your doodles to drawings, paintings, and sculptures from museums around the world. With Draw to Art, a doodle of a house could help you discover Houses in Auvers by Vincent van Gogh. A doodle of a horse could help you discover paintings of horses. And adding a stickman could help you discover this statue from Benin. We created a series of interactive easels with digital canvases, so people could try Draw to Art in galleries and cultural centers around the world, installing the first ones in the Google Cultural Institute space in Paris. So how did we make it work? Using machine learning, we trained a deep neural network to recognize visual features in doodles, like shapes, lines, and perspectives. We also trained it to recognize the same features in paintings, sketches, and sculptures from the collection. So Draw to Art can associate doodles to similar works of art. The best matches are then presented to the user, who can help teach the neural network by rating the matches to help improve the results for everyone. With Draw to Art, it's now possible to use creativity to discover great works of art from around the world in a whole new way.
So if I'm not wrong, the initial machine learning algorithm has been developed by Cal McDonald on that one. Another installation that happened to be shown in Shanghai was Art Palette here, where the concept is basically organizing artworks depending on a set of selected color. So this installation here is actually an extension of a web experiment that is available online. And that works like just a regular website that you can experiment. So there is a website, Arts Experiments, and you can have a look to how it works. You can take picture, you will select artworks based on the picture you just took. And I have another video where there is the fashion designer Paul Smith using it and trying to explain how he thinks he could use it in his practice.
If you can train your mind just to look and see, you'll find things anywhere. The thing about Art Palette, for somebody who loves colour, like me, it's just so useful to look through a whole collection of paintings or photography or anything where people have used certain colours together. I can't believe the enormous selection of artwork which is available, and that's really helpful. I use colour mostly as a punctuation mark. The art of colour was really essential for me because I was designing clothes which are so simple that you needed the surprise and you needed the colour. Henry Matisse was another person who worked a lot in colour, and he was absolutely genius at putting colours together. So you put blue and white together and they look fresh. You put orange and red together, they fight. My approach is, I saw a great painting and I just love the colours in it, so I just took the colours, and then that became this one, which we call the artist stripe, and that came just by looking at a painting at the Tate Modern. As a fashion designer, Art Palette can help me working with my staff. So what we'd probably do is start off with the colours that I've selected for that season, and then through the app just look at those colours and then see what gets thrown up. That can be so influential on how we design. The thing is about finding inspiration in the world today is looking and seeing. It's all there if you want it. You've just got to train your eyes to see it.
Yeah, so Paul Smith is a fashion designer, and here is another experiment based on fashion content. That is also a web experiment that has been initiated by Cyril. And the idea here was to create a friendly tool to navigate through 1,000 fashion images coming out from the archive collection of many designers' collection. And the idea was to combine kind of classifications, to be able to access the specific styles and colors or material of the clothes. Another thing that we are doing is, as we're producing these various experiments, we are lucky to present them during various talks around the world. So this specific presentation often very demanding in modifications and updates, almost live sometimes. So that's where I try to learn the difference between necessity and futility. So you know what I mean. One last category of work that we are sometimes invited to work on, it's when you come to an official Google product, like this one called now Art Selfie, and Cyril will talk about it.
Yes, so let's do a little case study on that, which started as an experiment and then evolved into a Google product feature. But first, let's take a step back. I like to show this work by Trevor Peglant whenever I talk about this work, because he took pictures of shores that are where some of the biggest data pipelines in the world go by. But obviously, they're buried deep down, so we cannot see them. And I find it really such a strong, poetic, and very simple way of talking about those hidden connections and how the digital world sort of juxtaposes with the physical world. But anyway, it could be a talk on its own, but I really encourage you to dig into Trevor's work. And inspired by these principles of landscape and hidden connection, a few years ago, 2016, we created what we call a TSNE map. So Mario yesterday brilliantly explained the concept of feature vectors and TSNE embeddings, so I won't go into too much detail. But we made this as an interactive online experiment, thanks to the help of amazing creative coders, including Nicolas Barradeau. If you don't know him, he's the father of mod. He's there. And this map lets you wander through this immense island that features hundreds of thousands of artworks, organized purely by visual similarity and automatically thanks to machine learning. And a particular spot really caught my attention, which we call the shore of portraits. And this shore features, again, tens of thousands of portraits that have been brought together across centuries, across continents, across time, all brought together in one place automatically. And that really called for to take a step further, to get to dive into it and provide a more personal way, a more personal connection to one of these artworks, maybe something that would be less intimidating rather than facing this gigantic content, finding which one we can show that maybe would really resonate with the person. And using this principle, this idea, one of the first prototype, this was, I think in 2015, it's called, we call it the portrait matcher. As you can see, very simple idea. We match the head orientation with an artwork from the database. Very straightforward, but people, I could feel when I was showing it, immediately connected with it and wanted to try and browse, then it really caught their interest. So we were asked to demo it and show it in a few places. I'm not going to demo it today because I promised myself to never demo it again. I'll explain why, but first let's see how it's, let's say, supposed to work.
Happening is with the movement of his head, we are matching different portraits, around the world from museums. And,
Okay, so here I'm happy. It's all worked well. Luckily, got great matches, and this is put confidence to continue and show it. But then this next video happened, and it's really hard for me to show it because it embodies so much pain that but you know, in between us, I thought I might as well show it. So that next video is in 2016. Mario and I were invited to show some of our work at one of the biggest developer conference of Google. It's called Google I/O in the US. And you know, full of confidence, I went and started demoing. And then fortunately, this happens where I move my head, but nothing changes on the right. The pictures keep just updating, but no update. And here there is a big, yes, I can tell already that I'm going to wake up sweaty at night thinking about that moment for a long time. And I had to move out, different country, hide in a cavern, reflect on the meaning of life, and maybe stop everything from there. And this is there. That's the point. See, you can see it's not this. Okay. But after I hid in that cavern, I got back out, visited museums, and I tried to gain inspiration again, confidence. Here, for example, at the Broad Museum in Los Angeles, this work from John Ahern. My wife wanted to take a picture of me with this guy. She found similarities. And then people in the room started taking pictures of me as well. And that was just completely surreal, really. And it reminded me of the kind of playfulness and the engagement that first got me interested in art. So I got motivated again, and I settled on making these kind of moments possible for everyone. And let's take this example with Damien Henry that Gaël mentioned. I'll cut the suspense. It worked in the L, but it wasn't without a sweat. So let's explain why. Now is the moment where you can feel free to take a nap, because it's going to get quite nerdy quite quickly. But afterward, we'll get back to the results. All right, so let's see. As I've heard 100,000 of times, the biggest source of success in ML is to get good data preparation, good data alignment, good data normalization. And in the task of face matching, having faces that are well aligned is critical to get good results. Now, that may seem like, okay, it's such a tiny step, but it's already fairly complex in the details. For instance, MTCNN is one of the most popular way of doing that, and that's already an ensemble of 3 different neural nets. I mean, it's already quite a task, and you have not even started doing the face match. So I thought, okay, the good news is working for Google, you can expect that a genius scientist would have done already a perfect implementation that would be already perfectly trained. And that was the case, so good to move on. Didn't have to worry too much about that, thankfully. So, okay, we got the phrase aligned. Now we want to get a feature vector. We want to get a way of measuring distance with some new images. And to do that, we need to measure the distance on something a bit more semantic than just pixels, because, of course, our eyes are so well trained on what makes faces similar. So, thankfully, again, FaceNet, which is a model created by 3 Google engineers, was pretty good at that task. It achieves, I think, more than 99% accuracy while trying to identify individuals. This is what they use to unlock your phone, for instance. And the good thing is that in order to accomplish this task, the model creates this latent space in which faces that aren't identical but similar get close to each other, exactly what Mario explained yesterday. And then we can use this latent space to measure the distance between existing vectors and find which portrait could be the most similar. So that's good, but then in order to measure this distance, we need to have this first data set of feature matches, and we have to have them for all the portraits in the database. Now that might seem trivial. You just run a for loop, go through all the assets, and be done. The problem is that as this scales to hundreds of thousands and millions of artworks, and let's say the pipeline takes the full pipeline from downloading the image, aligning the finding the face, aligning the face, getting the feature vectors, saving. Let's say the whole thing takes 5 seconds. Already for 500,000 artworks, it takes 30 days of computation, that for loop. Obviously, it's not an option. So we had to dive into the exquisite world of distributed pipelines. So now this can be quite a domain, and we are not engineers, scientists. So thankfully, we find a good ally in this task, which is called Apache Beam. It's an open source software originally created by Google, but now open source and maintained by Apache Foundation. And it does just that. It takes your Python code, and with a few tweaks, is able to spread the computation across thousands or even hundreds or even thousands of machines. Here we can see, for instance, this beautiful slide that a collective 30 days of computation actually took 3 hours and 30 minutes. So that became critical for many of the projects that we do, because as your dataset scale, you just have to use that. Okay. Now we have our feature vectors. We generate a t-SNE to kind of dive into it and get a sense of what's there, and we thought immediately that it would be really promising and also quite fascinating to dive into how this model finds similarities, how it clusterizes the faces, and which clusters were bigger, were smaller, or absent was also quite a talk on its own. But let's move out. We have our faces. We're confident that our features are actually meaningful. Now we need to pick up a distance metric. Again, I'm not going to dive because I'm not a scientist. I'd be the worst person to explain. So what I did as a coder is, instead of finding finding what would work, I just tested everything, plotted it, evaluated it, and rather picking which one seemed better, and then tried to find why this is better. And that was a really easier approach. So we ended up with the cosine similarities, and we are good kids, and like Patricio explained yesterday, if you have normalized vector, that comes with some mathematical bonuses. So good news is we can just do a dot product from a new feature vector across our entire data set in one go. Again, if you want to provide a good user experience, that kind of optimization becomes critical, because you have to match against hundreds of thousands of entries, and maybe you want to do that in the browser. Whew, OK. So let's recap. We have all our steps. We have alignment, feature vectors. We're able to search for nearest neighbor very fast on our browser. We have the artwork, time to evaluate the final result. And here we are. This is one of the first tests. And to this day, I'm still amazed how imaginative some of these results can be. So I'm going to show you a few. These were the very first results we presented at Google I/O in 2016. And I just can't get over Mario's match. It's just too beautiful. We presented it really, again, engaged with people, were curious, asking a lot of questions. So it encouraged us to develop it further. Here is the Zeitgeist UK the next year. Again, Gaël as a sad saint. I mean, OK, why not? And as we kept showing it, I realized very quickly that my email box was filling up with inquiries from people all over Google asking me to get their portraits. So they just wanted to get it, but the problem is that this was just a collab notebook. I had to manually run the script. But it was a good indication that we should really make something for everyone to use. Thanks to the help of incredibly talented people at Google, they made it into a feature in the app. We released it just before Christmas, shook our hand, tapped our shoulder, good job everyone, OK, let's go on holiday. Nothing happened for, I'd say, a month. And then we started to see some very intriguing activity on the servers, with the QPS rising very fast. And what had happened is that a few people, including celebrities, had heard about the feature, because it was a silent release in the US, and they had found about the feature on a cooking website, of all places, but really a cooking website had released it. And it just took off from there. We saw thousands and thousands of artwork matches popping up all over, and you know the drill. It got picked up by the press and by blogs, but even art press took it, analyzed it, and commented it in a very constructive way, which was also a very nice surprise. Even further, the Queen, Ellen, took it as a mean of expression and started to create her own matches, not using the app, but just people were using it as a cultural asset on its own. And that was also very, very interesting. Then the Four Kings in the US showed it on the talk show, not always in the best taste, but what happened is that it completely exploded from there, was really all over the US, eventually made the art and culture app first spot in the app stores, again, by showing and connecting people with art, history. That was very satisfying for us. And those are, let's say, vanity metrics that are very good if you want to ask for funding, but when we dive into the individual stories, then we get to realize that some incredible stuff happened. For instance, this woman in St. Louis was matched with her young portrait of her own grandmother. Or this man in the US, traveled to a different state to take a picture of his match. And on a more personal level, this is my grandmother and my nephew. And my grandmother just never allows us to take pictures of her. And this time she insisted that we took a picture of her and that we found the match. And we were just stunned by the fact that she looked so similar to Eleanor Roosevelt, at least in this painting. And really, during this very picnic, Art Selfie allowed me to talk about art, biometrics, AI, at a completely crazy and unprecedented level for this kind of reunion where we talk about usually a very different topic. And that, I must admit, is a personal lifetime achievement. And speaking of life...
Okay, I keep your transition. Speaking about life. Sorry. So what it is about. That's going to be the last project of our presentation. So the story behind the life experiment, it's called like that, started by an email saying basically something like that. Hello, everyone. We have a collection from Life magazine. It's about 5.5 million images. Feel free to have a look. Say, OK, 4.5 million of images. Say, OK, we can browse. You can just try to open it. 5.5 million. So it was just OK. But it's Life. Probably you all know the magazine. It's a very famous magazine that has been published since 1936 to the early 70s. And it makes almost 40 years of weekly publication, mainly based on pictures, with the most famous photojournalism photographer during that time. It's pretty well known because all main world events since World War II has been covered by Life magazine. Till even the landing on the moon. So they were the first one to show the picture of Neil Armstrong on the moon. So basically, it's literally 20 years, the 20th century, photo album. And actually, there was this issue of handling 4.5 million of pictures. We can run it like this, because I like the slide things. So, but it's kind of freaking out when you have such huge amount of data. So it's maybe the right time to use machine learning one more time to help you to organize all that. And as I've said before, I'm kind of a newbie in machine learning. I'm curious, but I'm a newbie. So I had to learn, and I did several experiments. I had to try, and the first thing I tried with machine learning was trying to classify and detect objects in pictures. So that was the first thing I tried. So I had this kind of new tools in my toolbox. So I used that tool to process the 4.5 million of pictures. And what does that make? So it brings out labels based on what it's discovered in the image, based on all these feature vectors things that Cyril explained just before. And then it took out all the possibilities of the labels. But there is one thing that when you run such a model, so one picture not only comes with one single label, as you can see in that example. So, for example, a cat can have a high percentage of accuracy with being a cat, but also a lower accuracy being a mammal, and even a really low accuracy to be, for example, a bunny or something like that. So that's how you filter what could be a good answer or a bad one. But for this experiment, I ran everything, and I had all the classification for the images. So that came with a bunch of labels. It's more than 10,000 various labels associated with the pictures. And that wraps up, in a way, the picture of their life archives. So then came the problem to say, OK, how could I just access the content, access the image through these labels? So came the idea just copying the most obvious tool to organize words, a dictionary. And actually, there is this dictionary that we all used, at least at my time, I don't know, where you have illustrations, keywords, definitions. So I tried just to replicate this kind of dictionary by organize all keywords by alphabetically. Then when I've seen groups of keywords, I make some kind of definitions, taking out from Wikipedia, and then you end up with a list of keywords. And also random picture coming up every time you come on a website. You have another overview, another sub-selection of the 4.5 million pictures that are behind that. And then you can start to dig into each keywords, and you're able to access a bunch of images. And by serendipity, just getting lost in the whole collection, jumping from cat to mouse, coming back to cat, going back to I don't know what. So it's really something that came out of a print reference, the dictionary. And so I always been interested in printing stuff. So I realized that thing. I get my props here. So I also used the automatic tool that you can actually code in InDesign. You can do JavaScript in InDesign. So you can generate also automatic layout in print like this. So that has been automated. So actually, I made some rules. But then all pictures that are printed here has been randomly taken out of our data sets. So every version of the newspaper that I produce here, just by using these automatic tools, are unique in a way, because they have all a different layout on top of a base that I've designed. So there is rules that are followed, but then every single new version has it. So I've got few of them, so I will just throw it in the crowd so you can pick one up if you have time, if you're interested. So print stuff, and one last thing about that project comes to misclassification. And misclassification is a really wonderful topic in machine learning. I really enjoy it. And it just shows that machine learning is a great tool, but it's not perfect. And it's really far from being perfect sometimes. So it makes me remember a quote that had been auto-generated by a scenario by Ross Goodwin, saying, "It's going to be a beautiful mistake," something like that. And I really like that quote, beautiful mistakes. It's really beautiful. And it's really interesting because the mistakes that the machine learning models and what came out of it are full of poetry, in my opinion. And the biggest distance between reality and the expectation that we can have on a picture is also the easiest way to understand why machine has been tricked, has given a wrong answer. So, for example, here, can you imagine what the machine discovered in that image? You have an idea? Anyone? No? That's a xylophone. And you can understand why it was wrong because it has some feature related to xylophone, but I got more of these. For example, the woman here, what do you think it could be? For the machine, not for you. For you, it's basically someone who's working on a mosaic, but for the machine, it's a pizza. And then here you have this whole card with the shadow put on the table, I don't know. And what do you think that the machine could see? What? Building? Building? Oh, yeah. That's good.
Yeah, building.
Nice try. They see a laptop.
Wow.
Because I can see the key now. And this girl who enjoyed the apple pie here, which one? I heard it. That's a zombie one. I love that. I can spend my days just looking at the mistakes. That one, for example, that's the Star Trek Enterprise spaceship. You know, it's been defined as hi-hat for drum. All right, one last one for finish. That one, maybe more tricky, poetic sculpture. It's been defined as skateboards because of that.
No.
That's so cool. I really like that. So even if machine learning makes me discover that image, for example, I'm now looking at it and I'm sharing it with you. And so it made me think that actually someone really worked on that not so long ago. He sculpted these models. And maybe he was also a freelancer like us. I don't know. He maybe was working with someone else, like we did, in a cool 16th century workshop in Italy. I don't know. And maybe they had different skills. And maybe they have been commissioned by a big commissioner to do it. I don't know. Actually, that sculpture is a trace of their way to do things at that time, using their own tools, sculpting at that time. And for us here all today at Grow, our tools are computers, codes, and Stack Overflow, basically. And we are all part of something called culture. And we are all probably have our own labs, everyone, like we hear about London, I know Munich, that we are all spread. But innovation and creativity had a strong link together since it has always happened. Think about Leonardo da Vinci or all these amazing artists at the time. And it always happened in unexpected places. We had a workshop, we met, we did a bunch of things, but here maybe today, it can happen here at Go. I will leave on that. Thank you.